So let's talk a little bit about the programming process. Programming is just that, it's a process. It involves lots of different steps, and these steps are very iterative. So the first very important step is understanding the problem and the client specification. So it's really important when you sit down to not just open up your computer and start writing, but to really understand what's the problem, what is the client looking for, and really make sure you have a good understanding of that before you ever even think about how to solve it. Now, in this class, basically I'm the client, but this still applies, right? You need to make sure that you have a really good understanding of what I'm asking you to do before you ever think about how you're going to do it. That often involves asking follow-up questions, like what do you mean by this part? What should this part of the requirement be? It's really important to ask those questions first. Then once you understand the problem, then you design your solution. Now again, you have not touched the computer yet. In designing your solution, oftentimes you're going to do it on paper. So you're going to write out what's called pseudocode, which is kind of part English, part code mix, right, about describing how you're going to solve this problem. Sometimes it's going to involve drawing sketches. If it's a graphical interface, you'll sketch out what you want your interface to look like and what's going to happen when the user clicks this button. You'll oftentimes draw your class design. So if you're working on a solution that involves multiple classes, you need to sketch out what does this class do and how does it interact with this other class. So you need to think about the design of your solution first. And only after you've done these first two parts of the development process, then do you implement the solution. This is where you start writing your code. Okay? This is where you take that design and you translate it from pseudocode into code. And then you test that solution, and once you test it, you go back to the code to resolve bugs. Oftentimes, once you test the solution, you'll also say, I need to actually go back here and design my solution differently, or maybe I need to go all the way back to here because I realize now in testing, I didn't really understand some of what I was being asked to do. So all of these steps are iterative, and you might jump back up this chain many times and then come back down it, but it's all part of the programming process. So you will be writing your code. So talking a little bit about this step here, this implementing the solution, you'll be writing your code in a development environment. Now there's lots of different development environments that you can choose. Some are very lightweight, meaning they're very simple and they don't offer a lot of features, but they're also very easy to use. Some are more heavyweight or what's called integrated, meaning they offer a lot of features, which is great, but they also there's somewhat of a learning curve with learning how to use them. Eclipse is one example of a development environment. NetBeans is another. JGrasp is another. There's also, of course, the idea of just writing in a text editor and compiling from the command line. All of these are options for you, and you are welcome to use whatever environment you choose, or not use an environment and just write directly from a text editor and then compile and run through a command line. In my videos, I'll be using Eclipse. I like Eclipse because it's free, it's very powerful, and it's also something that's used a lot in the real world. So I like the idea of just getting in there and getting used to a system that you might actually end up using someday. The drawbacks of Eclipse are that because it's so powerful, it sometimes, again, has a steep learning curve. So it takes a little getting used to. But once you get used to it, there's really a lot you can do with Eclipse, and I think it's a great environment. So if you have never used an environment before, I'm going to encourage you to use Eclipse. If you have a different environment you want to use, you're welcome to do that. So I don't require you to use one particular environment. But whatever development environment you choose, you use it to write your code, and you then compile that code, and that code gets translated into what is called bytecode. Your bytecode is stored in a .class file. The name of that file will correspond to the name of your class. So if you wrote your class, your student class, in a file student.java, your bytecode will be in the class student.class. The Java Virtual Machine, or the JVM, then translates that bytecode into executable code. Now, each platform has its own Java Virtual Machine. So if you have a Mac, it's going to have a different JVM than if you have a Windows machine. And the executable code created by that virtual machine is going to be platform dependent. So again, you can have a single class file, and your Mac JVM is going to generate a different executable code from that class file than would a Windows JVM. Okay? But Java can run anywhere that has a Java virtual machine. That's what makes it platform independent, because you write your .java file and you compile your .class file, and then that .class file can run on any machine that has a Java virtual machine, which is most machines these days. So that's what makes Java what's called platform independent. So here's just another way of thinking about this process. You write your code in some sort of editor. You save those statements in a .java file. That's read by your compiler, which generates your bytecode, the .class file. That bytecode is interpreted by the Java virtual machine, and that results in your executable code, which is then run. So this is kind of the process of how your actual code that you type gets run and executed by your machine. Let's talk a little bit about syntax and semantics. So we talked a little bit already about some of the Java syntax rules. Well, syntax defines how, in general, how symbols, words, identifiers can be put together to make a program. So the syntax is what defines your language. Java has certain syntax rules. C++ has different syntax rules. Each language comes with its own rules, and those rules are called the language syntax. Okay, so some of the Java syntax rules are that it's case sensitive, that brackets must be matched, etc. Whole set of rules that we'll learn about for Java, those are called the syntax. Semantics, on the other hand, semantics is more defined what the statements mean. So semantics are more the purpose of the program. Okay, semantics isn't defined by a language, it's defined by the problem that you're trying to solve. So a program that is syntactically correct, meaning it follows all the rules of the language, meaning it compiles, might not necessarily be semantically correct. So your program might compile and run, meaning it follows all the Java rules, and you can generate that .class file, and you can then convert that into executable code and run the program, but maybe it doesn't do what you wanted it to do. That means it's semantically not right. It's got a problem with the semantics, okay? So you always need to be thinking in these two ways. From the syntax perspective, is this file going to compile and run? Does it follow all the rules? But then, okay, assuming it does it do what I want it to do? And that's the semantics, okay? Syntactical problems are often a lot easier to solve because we can solve them at the compile stage. Always easier to solve problems at the compiler stage than at the running stage. Runtime problems are much trickier to fix. So we have these different kinds of errors. We have compile time errors. These are, again, problems with the syntax. So if you don't follow one of the Java rules, you're never going to be able to compile. So if you leave off a semicolon or if you have a missing bracket, for example, that's a syntactical problem. It's a problem with your syntax, and it will happen at compile time, meaning you will never be able to compile your program, and no bytecode, no .class file will be generated. So that's kind of the most basic type of error. It's also kind of the easiest error to fix because the compiler will help you find where the error is. That's not always a simple problem, but it's easier than solving problems later on. So those are your compile time errors. The next kind of error you might have is a runtime error. So this means your program compiled, the bytecode was generated, and the program ran, but it didn't maybe run okay under all or some conditions. So something happened in your program that caused it to crash. That's a runtime error. An example of that is, let's say you wrote a program that was asking the user to enter some numbers and you divided those two numbers. And let's say the user enters a 0 and your program tries to divide by 0. Well, that might crash your program. Your program might compile fine and run fine if the user enters all sorts of other numbers, but as soon as they enter a 0, perhaps the program crashes. Okay, so that would be an example of a runtime error rather. These can be difficult to solve, runtime errors. And then we've got logical errors. Okay, so these are errors that arise when your program compiles fine and runs fine under some conditions, but doesn't crash. It just doesn't give you what you want under other conditions. So for example, if you had a program that was calculating temperature, converting from Fahrenheit to Celsius, you might have an incorrect formula in there somewhere so that your program is running, it's not crashing, it's giving output, but the output isn't correct. And these can be the most insidious type of errors to track down and solve, these logical errors, because it's not entirely evident what's going wrong. And when you have compile time errors and runtime errors, Java gives you some assistance in tracking those errors down. But logical errors mean your program is running. Nothing is happening. From Java's perspective, it washes its hands of your program. Your program's great. And it's up to you to track down and find those errors. Okay, so let's talk a little bit about the different kinds of program structures. Java allows you to write two main kinds of programs, text-based programs and graphic programs. A text-based program is a standalone application. Input and output comes from the console. That basically means the keyboard. That means you have a little text output window where you see the output of the program and you can type things into that little input window, again, text things, and that's the way you interact with the program. we will start with the majority of our program just being text-based applications. Text-based programs have that special main method. Again, that's what runs when you launch a program. Now, Java also supports graphic programs, and there are two main kinds of graphic programs: standalone programs, which are called GUIs, Graphical User Interface, GUI, and also applets. Standalone GUIs are launched from the console in the same way that we launch our text-based applications. They can also be launched through a clickable file called a jar. Just like our text-based programs, GUIs also have a main method, and that's what launches when you run that program. But there is another kind of applet, another kind of graphic program. It's called an applet. Applets do not have that special main method, and they're just structured a little bit differently. Applets are designed to be embedded in a website. So there is no main method that launches. There is no way to run this from the console. But the way that you run an applet is by embedding it in a web page, and then it launches when you visit that web page. So these are the three different kinds of program structures that Java supports. We're going to look at all of them. We'll focus mainly in the beginning on text-based programs. We'll then spend some time talking about GUI applications. Personally, that's kind of my favorite stuff that we talk about. It's really fun writing these kind of applications because they're really interactive and you can do a lot of cool things. And then we'll briefly touch a little bit on applets. Applets aren't as big as they used to be because of some security issues with Java, but they're definitely still used, and so we'll talk a little bit about them as well. But let's start with just our main text-based applications. So in a text-based application, again, it's all text input, text output. For output, the way that we output things to the screen is with system.out. So this is actually an object. This is one of those, for now, just accept that this is an object, and we'll explain why later type of moments. But system.out is our object, and we have two primary methods we invoke on that object. One is print, and one is println, or println. Print outputs whatever text you send it without advancing to the next line, and println prints whatever text you send it and then moves on to the next line after it's printed. Now we also need a way to get text input from the console, and we do this through the scanner class. The scanner class provides us a lot of different methods for reading things from the user, and we set up a scanner object from different sources, but we're going to primarily, for starting, focus on getting input from the keyboard. The keyboard is represented through the object system.in. So in order to use the scanner class, you have to do what's called importing. We're going to talk more about this later on. This whole little next couple slides is going to be very much use now, understand later. But the scanner class, you put this line at the top of your program to import the scanner class. It lets you use it. And then what you do is you create a scanner object with this line here, scanner, and then you give it some name. I'll typically call it scan. You might also call it input. And then you create a new scanner object that reads from some source. The source is going to be system.in. Again, that's the keyboard. So what this line of code does is it creates a new object of the scanner class called scan. And that object is associated with reading input from the keyboard. Now, once that scanner object is created, you can invoke all sorts of different methods on it, but the one that we'll invoke the most commonly is next line. And essentially what this method does is it reads in a single line of input from the user. They can type and type and type, and as soon as they click enter, that triggers the next line method. So that basically says read up whatever text the user typed until they clicked enter. It sends this method invocation, that's what this is called. It's called invoking a method on an object. What it does is it returns to you text, and that text is returned in the form of a string that you can then store in a variable. Now, I'm using a lot of words here that I haven't defined. We're going to define all of these, so it's okay if this doesn't make sense yet. Just start getting used to kind of what these words sound like, and I'm going to define all of them as we go along. Now, in addition to this next line method, there are lots of other methods in the scanner class, and we'll look at some of them eventually. If you ever want to look at what methods there are, you can just Google Java Scanner API, and the first link that comes up will be this link here, which is the description of the scanner classes, of the scanner class. And this is what the Java APIs look like. We're going to look at these in a little bit for lots of different classes. But for any class that Java provides you, it provides you a description of how you create these objects and all the methods that come with these objects. Here is the next method, for example. The next line method is the one I just talked about that returns to you a string. So these API pages, there's one that exists for every class that Java provides you, and you can look these up, but we'll deal with them a little bit later when we talk about using Java provided classes. Okay, so the last video, we're going to stop here for now, and the next video and last video in this little series, we're going to go through an example of using Eclipse, and we're going to use Eclipse to create a text-based program and output things to the console and input things to the console.